Howdy, everybody in YouTube land. So, what we have in front of us today is some stuff someone shipped in to me. So, a friend of mine's significant other has sent this to me because there's something up with it. It does not work, and we don't know why. So, I think this is an SE30 board. So we have that. Let's see what else is in here. I don't know what that is yet. And then we have, I don't know what this is either, but it's stuck to that. So we have those. So let's set. Is there anything else in here? No. So let's set this box to the side. First off, let's take a look at this. Oh, that's a reloaded board. Yes, so that's going to make for an interesting troubleshooting video, I think. What do you think? So, still has all the original parts. Oh wow, yeah, that's shot. Can't have that. I'll be amazed if that works. And that's just enough to cause problems. So, some of the original 74 F258s, which I never keep those. I always change them out with new because they just so commonly fail. There's a new ROM, at least, new video ROM. We have we have the same glue chip, which is original, obviously. We have the processor, but it doesn't look like he put a socket in here. He soldered it direct. So if it's bad, yeah, good luck getting that out. The PALs are original. Man, they're rough too. So it's looking kind of rough because just the quality of the parts. Like, look, they just used the original UE8, so that's. I mean, it could be okay, but it's one of those things I would change. Outside of that, I don't really see anything out of the ordinary. What I do see, though, is I'm seeing missed solder joints. Like that one there is missed. Let's take a look at the other ones. Yeah, we got a missed solder joint there. You can see it right there. The fourth over from the right. That one's missed, so that's an issue. See, let's look over here. There's a missed one there, for sure. And then let's take a look at the glue here. Yep, there's some missed solder joints on that one too. Well, maybe. Yeah, there is on the end at least. Yeah, so that's what we got going on here, I think. Well, that's part of what we got going on here is we've got some of these PLCC chips that just... Oh yeah, look down there. There's a few of them that are missed solder joints. It's definitely a problem. There's one right here, missed two. Fourth one up. You can see. Take a look at the swim. Yep, we got one missed right there in the middle. Possibly on the left hand or the right hand side too. Actually, all through that. I think that one's forgotten to be soldered. Yeah, I think this one was just tacked in. It was never finished. Yeah, it was never finished. It was just tacked in. It was never finished. Alright, let's take a look at the SCSI chip. What do we got going on here? Yep, much of the same thing. Just missed solder joints. Let's look at you, the SCC. Well, that one's good. There might be some... No. Yeah, there's one missed right there. Just barely. Second one up. Just barely. Yeah, so... I think that's what we got going on here. That one's really rough. Ooh. See, here's what I would have done. Everybody has a different technique, but here's what I would have done. Anytime I've got chips that are, rough like this because they came off of a battery bombed board, right? So what I do with these is I pull these off of the old boards and I sand them down with a sanding block just a little bit to break through the crustiness, and then I re-tin the pins. That way you don't end up with something that looks like that, right? Because that is just not a good connection. This stuff has to be cleaned up. Whether it's vinegar, sanding, whatever, you've got to clean that up. So that's just tips. These look original. So they were pulled off the old board and put over here. Anyways, let's see. Looks like that's new. That's original, which it has to be. That looks like it was heated up and melted a little bit, but that's not a big deal. That's just all cosmetic crap. It's not a big deal. See, opted for the ROM sim versus the chips like I did on mine, if you remember my previous video. See what we got going on back here. Oh boy. Blobular. Totally blobular, man. That's fine. I want to test them and make sure they're not open, but don't see any missed through hole joints here. Everything looks good as far as I can tell. So this is just an initial inspection. I'm looking for any possible sign of an issue, which there's multiple. So, oh, we got another one here too. Forgot to solder the ROM jumpers. So this thing isn't going to do anything without that. No, so first things first. I want to verify the operation of the video circuitry and all that stuff. So what I'm going to do is I'm going to go ahead and just grab the RAM and ROM sims, which I'm assuming are in here somewhere. I think. Are they in there? Yes, they're in there. There's some RAM in there. There's a Mac Sim. The problem with these is the boards tend to be a little bit on the thin side. So, alright. We have that, and I don't know what this is. This feels like an Ethernet card or a video card or something. I don't know. But I'll set that out of the way for a minute. But, alright, so now we need a machine to throw this in to test it as it is, which I know it's not going to work for several reasons, but I want to test it as it is, and I want to confirm what it's actually doing, so. Alright, which machine? Which one should we use? Well, thinking about this one on the end, because this one, I think, yeah, okay. So this one actually came from my same friend, and I got this one from him for the purposes of testing boards. So, yeah, we'll just, yeah, because this one's beat and screwed. So, yeah, we'll just pick you, and we'll use you to test the boards. This one actually has both ROMs. It has this one. It has this one. So, I think we're just going to use the original, because at least the original I know what we got going on. And, I don't know if this 2-chip memory actually works in these machines. I think it does. Yeah, these machines don't take advantage of parity. That was only a PC thing on some chipsets. But, anyways. It's not going to do anything. I already know it's not, but I just want to verify it. Because, I mean, the ROM jumper's not even soldered down, so there's no way it's going to do anything, but yeah, I need a harness extender. This is fun. Alright, so here we go. Let's confirm my suspicions. Alright, what do we get? As expected. Hey, at least the video circuitry's working, so Honestly, that's amazing. With how bad those chips looked, they're actually good. Huh. Well, I'll take that as a win. Alright, yeah, it's doing what I expected it would. The stripes. So, the stripes, or the SEMA CMAC, or however you pronounce that, all the different patterns you get on the screen when the system doesn't boot and SC30 doesn't boot, that's all due to the type of video memory, the brand it is. Like this one is just jail bar stripes, which, hold on, I gotta put this down. So the jail bar stripes are generated by this TMS memory. I think the NEC memory is what generates the weird pattern. So, okay, soldering iron on. Step 1 is to attempt to solder the ROM socket, because this and this has to be jumpered on these boards for it to work properly. So, and I think, if I'm not mistaken, I don't have the schematic in front of me, but I think, if I'm not mistaken, the arrows indicate which has to be jumped to turn on the ROM sim. So that's what we're going to do. We're going to go ahead and solder that down, and then we're going to try this thing again and see what happens. Alright, so it's all soldered. The jumper's now in place. You can see it. So here we go. Let's try it again. See what we get. Alright, we got the same problem. Not unexpected, considering what I saw with the rest of the PLCC chips. But at least that is no longer a problem. So now we need to start soldering all of the pins on the PLCC chips. Alright, so I'm going to do a few things here. First thing I'm going to do is I'm going to solder up, or try to resolder this glue chip. Check these two vias and try it again. The rest of these don't matter so much to get any kind of a video signal, but these three do for sure. One thing I found right away, though, is there is a solder blob. You can see it right there. Like between pins 5 and 6 over right there. You can see it. So there's a blob in there that's got to be cleared out. So I got to fix that and then resolder that. It's possible I have to pull this FPU out because it is looking very bad. Plus you can see that very first pin on the left hand side is not even soldered. Plus you can see it kind of blobby down here on the very rightmost pin. It's not good. So that's probably an issue. But I don't know for certain yet. But that is definitely not the best looking chip I've seen. So I have that to pay attention to. But first, I want to get this chip here, these two here, and I want to see if that restores operation. If not, I'm going to pull you and get you out of here because there's just no way. So that's going to go away. And then we'll try it again. We'll keep hammering at this until we find out exactly what the cause is. Alright, so I went ahead and resoldered this and tried to catch all the pins I possibly could, including I got out that solder ball that was right there. I'm hoping it didn't damage anything. It's very hard to say. Some of this is questionable, like that one on the very end. I don't know if it actually soldered, but the problem is that chip is corroded, so I'm not surprised. This should have been cleaned off before the chip was ever mounted to begin with. But that's done, and I went ahead, and there was like 2 or 3 broken connections on these vias. So there's so many odds stacked against it. So I went ahead and resoldered all of that funness. So all of that's done. So these 3 have been taken care of. I want to see what it does now. I haven't pulled this guy yet, and it needs to be pulled and cleaned up. So that's got to come out. But before it does, I want to check and see what else has gone on with it, if it's going to make a difference in how it acts. So here we go. What do we get? Nope, nothing. So we got to keep going. I want to remove this FPU because it can hold up the bus too if it's bad. Am I even getting any warmth through there? Yeah. CPU getting warm? Yep. Those videos are getting, this one's getting warm quick. Alright, you're coming off because of how bad you look. Alright. Time to keep going. Alright, so I got this chip removed out of the way so we can eliminate that being a problem. And one thing I noticed right away is you can see, at least with that solder joint there, it never even soldered to the board. It never bonded. And I'm noticing that with some of this stuff. It's just like they're not soldered properly. This is never going to solder properly because the pins are still heavily eaten up with acid. So that'll never work. And it's probably no good anyways, but I'm going to remove that out of the equation. We're going to try this again. Also, the sound chip has similar issues. I need to go through and clean up and resolder that as well, so I can, if it still doesn't work, I can listen to see if it's even trying to make a sound. Yes or no. That'll tell me a lot of things. You know, if it's even trying to run from ROM or what. So, yep, slowly eliminating it one variable at a time. Alright, there's some strange issues going on here. So, I resoldered the sound chip because there was some missing joints there, too. That's all nice and good. Now, there's no chime when I plug the headphones into it, which they're on my head right now. And perhaps worse is the reset button doesn't do anything. So, there's something strange going on in there, in that neighborhood. So, I got to figure that out. Alright, so here is the deal. This one, unfortunately, looks like it's beyond the typical just resolder some missed solder joints and hope it works. Because there's a bunch of them. There was a bunch of them I had to go through. Now, these I haven't touched yet. This one, these three here, I redid. I also touched up a couple over there, but that doesn't matter. And then we have a problem with the reset line not working for some strange reason or another. So now that we're actually beyond the point of just throwing some solder on it and hope that it works, now we're going to have to do some actual troubleshooting. So first thing we want to do is we want to set up the bench power supply to put out both 5 volts and 12 volts because that's what we need to run this board on the bench. I also have to plug headphones in to the sound port so I can hear the chime if one even comes up. But before I even get to that point, I'm going to set up the oscilloscope, remove the ROM, and I want to see if this thing walks the bus. Because that'll tell me if the CPU is any good or not, and if it's coming out of reset, and all of that other fun stuff. So let's get set up for that. Alright, we are hooked up, so we should be able to turn the power supply on. 12 volts goes here, 5 volts goes here, and we got grounds. So everything's good there. So I should be getting bus activity on this socket here. And I am not. I'm getting a weird voltage. There's 1.6 there. Let's see what else we have going on. I'm getting all kinds of random. 1.6, that's not right. We've got a severe failure. Let's see, 4.5. So that's right. That's right. 4.5. 1.75, 4.5. We got the CPU's powering up in a random state, and we're getting random voltages that are just not right. Like these two pins at the bottom are not right. So, this is the data bus. Oh, no, there we go. There's 4 volts. 3.5 volts. Yeah, there's a... No. Something's wrong here. We've got a serious failure in this board. It's probably the CPU. Plus, the reset button doesn't do anything either. And I even tried jumping this where there is no button and it doesn't work. So, yep. Time to stare at the schematics for a bit and see what in the world we've got going on here. Because something is incredibly wrong. Like, okay, so here's the ROM select line. There's the address 123 and then 4567. So we go 123 4. Yeah, that's not good. 5, half a volt. Pin 6. Something's up here. No, 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 no. Yeah, no, no. I think that CPU's gone. That's a shame, because it is not socketed. So, I think the next course of attack here is to pull this CPU and put it in one of my known good boards and check it. So let's start at the beginning here. So we have a reset signal that comes out. I checked this with the oscilloscope and it's low. And it doesn't toggle when I toggle the button. Now, unfortunately, this recreated schematic, they didn't draw the lines to the reset buttons. It's kind of dumb, but they didn't do that. So that has to be done still, but the point is, if we pull up the original schematic, we can kind of see that here. Well, when I toggle the reset line, nothing happens. So what I did was I checked the reset output. So if we go, which is, what was it, pin 5, if we check the reset output, which is this guy right here. So 1, 2, 3, 4, 5. We're shorted. So the reset line is shorted to ground. Why? So now we got to figure out why that is. Alright, so here's what I've done so far. I took this chip out and I fed 5 volts into the reset line. And what I wanted to feel for is if individual chips got hot. None really did, but they started getting warm. So I fell on the bottom and the board got scalding hot where the tray snakes all the way through because it's connected to multiple chips before it ends up over here. Well, this section here was cold and then it got hot from here on back. So wherever the short is, it's going to get hot up until the short ends and then it'll get cold because there's no current flowing anywhere else upstream. It all stopped right here. So I pulled this chip out and now the short's gone. So now I'm going to wire this board back up. I don't know if the swim chip is bad or if there was a solder blob caught up underneath here. I don't know. So I'm going to wire this board back up and then we're going to test it again. And I'm going to scope it again and see what we got going on. See if that processor is even alive. Alright, so now we're back on. And let's see. There we go. That's exactly what I'm supposed to see. Each address should be 1/2 the frequency of the adjacent address. And that's exactly what we have. The CPU is running. We now have and that explains the weird voltages because the CPU was caught in reset, right? So there we go. So let's do a reset now. Now the board's running again. All right. We're good. So now we can test this guy once again in the chassis. Now with the ROM installed, we still have no chime, but we're running code now at least. It's just running the same loop over and over and over again. So, but it's running code from ROM. Now, that SWIM chip is not installed, so that might be what it is. Or it could be one of these other ones not soldered properly. It's really hard to say, but the important thing is it's executing code, or at least it's attempting to, from ROM. So, we're further than where we started. So, let's keep going. Alright, so I got the swim back in place. Still didn't get a chime, so now I have the SCC and the SCSI chip removed. And one thing I noticed is this 53C80, which is the SCSI chip, there's some nasty pins on here. Look at there in the bottom left corner. I don't know about that one. Zilog 8530, there's some sketchy ones there too. I don't know about this one either. So anyways, I pulled those. So here we go again. Let's figure out what happens. Whoa, hold on. I just heard something. There we go. It chimes. Holy crap, the board is booting. So here's the way I do it, and everybody has a different way of doing it, but how I mount a PLCC, especially a used one, what I do is I grab my sanding block here, and I actually grind down all of the crud and crap off the pins as best as I possibly can, right? I mean, they're not perfect, but they're better than what they were before. I try to make it flat as I can. I do the same thing for both chips or any chip that I'm putting in there. And then I make sure that the pads have plenty of solder on them. And then I take some flux and I'll take some, put a bunch of flux down there. And what I'll do is I'll line it up as best as I can and I'll reflow solder them back in place. Then I'll grab the wand and touch up any pins that might have been missed. But that's typically how I do it, and I've not had a problem with using that method yet. Everybody's different, but that's how I do it. So the same goes with this. Like this really nasty, disgusting coprocessor, I'll probably just do the same thing. Just clean it up with this pad. It'll make it easier to solder down, and then you can re-tin all of the leads, so you don't have any problems and it won't re-corrode. But so that's what I do, and that's how we're going to remount these chips back. Since removing these chips made it work, it was probably bad soldering. Could be a bad chip, but with as bad as everything else was as far as the solder job is concerned, it was probably that. So let's remount it all back, and that seems to be really what it's been so far, is just not good soldering. And plus these two being missed, which is really easy to do if you're not paying attention. Just do that. But it's just really been bad soldering, not really a failed component yet. So perfect. Let's go get this guy mounted and we'll come back and try it again. And just like that, it's soldered. It's not perfect, but it's in there. Reflow soldered into place. They're all bonded. They all have a connection. So at this point, it's a matter of connecting everything up and hoping that the chip is actually not bad, because anything is possible, really. Especially when something is this old. Alright. What did we get? Oh, hang on. Gotta put the ROM back in it. Yay. Chime. Okay. Now, we know that one's good, so we can go ahead and put the SCC back in using the same methods. So we sanded our chip down like we explained earlier in the video. Then I'm going to grab my chip quick flux. This stuff's hard to clean off, but that's what I use. I just take a bead, lay it down here, nothing crazy. I don't drench this thing in flux. I mean, you can if you want. It's not going to hurt anything, but I just don't like doing that because all it does is just create a mess for me to clean up later. If you got an ultrasonic cleaner, which I do not, but if you have an ultrasonic cleaner, it doesn't matter. I mean, you can just drench the whole board. But unfortunately, I do not have an ultrasonic cleaner, and I don't want to make a bigger mess than I have to. So, okay. Alright, you are good. Make sure you line up the pins properly and install the right chip in the right spots and not backwards. So, that helps immensely. And then we just line this up as best we can. I'm going to use my little... These aren't forceps. These are, I forget what the heck they're called. And get it lined up, which it's not. And then we reflow this guy in with my hot air tool right here. Alright, the SCC is installed. Everything all soldered in properly using the reflow soldering technique. Didn't even have to touch that one up. So, here we go again. One chip at a time. If this one works, then I'm moving on to that one. And then, that's going to be fun to solder because it's almost too big for that gun. But, it is what it is. Here we go. No. The SCC is bad. Sure is. Oh, nope. That was weird. Didn't get a chime. Still kind of hot, so maybe that's why. No. Strange. That's holding me up. No, that thing's getting hotter. I think I found the problem. That guy's bad. We're going to have to get a new, what is that one? An 8530. We're going to have to get a new one of those. Alright, for grins and shiggles, I decided to clean up the coprocessor and sand it down a bit and get it mounted with some reflow soldering. I had to patch this corner up because it didn't have enough solder, but now it's in there. Let's see what happens. This still has the original chip. I noticed once it got super cold, it was fine. When this thing got warm, it was acting up, so it probably needs replaced. But we'll see. Nope. No chime. Could be a couple things. It could be this acting up again, or it could actually be this. Ooh, that sucker's hot. Still. Now, it's been cooling off for the last few minutes, so... That is a no. It is not cooperating. No, this guy must be bad. Well, it's between one of these two anyways. It was fine with that installed. No, chimed again. Must be this guy, because that's what it was doing before. Needs a new SCC 8530. Alright, well, I'm going to have to put that guy on order, but other than that, the board seems to be working. Let me get it all back in the case and see if it boots or blows up or something. Alright, we're all plugged back in. Coprocessor's installed. All the chips are back on. The only thing is I had to remove that, which kind of got ruined. It's, falling apart. So that's junk, but here goes nothing. That is a negative. Yeah, it's probably acting up again. Oh, come on. Going for chips. It's not in there very good, but that is a no. I need to get a speaker hooked up so I can tell if there's any kind of sound at all, but that appears to be a no. And I'm pretty sure it's that, because everything was fine until I put that on there. So, alright, let me go figure out what's happening here. Alright, speaker's connected. Hey, we got a chime. Nah. We're not getting video initialization. Now, we do have a ROM installed here. I wonder if that ROM is incorrect for this board. Because you'll get this if the declaration ROM is not seen by the system. There could be multiple reasons why it's not seen, but if it's not seeing that, we're going to get this issue. So we need to take a look at that. Actually, before I went ahead and got a ROM, I decided to put the SCSI and floppy controller in, and guess what? Not really any activity from the floppy or SCSI. It's not doing anything. That's weird. Alright, so the Zilog chip has been removed. I'm just waiting for it to cool down now. The wand is still cooling down. I'm hoping that that's what was holding me up, because I was getting a consistent chime every time until I put that in, and it became intermittent, right? And then when I hooked it all up, I got nothing. So it's either going to be one of two things. It's either going to be this, or we still have an issue over here, like a missed connection or something. It's hard to say. These two are installed properly, so unless they're physically bad, I know they're connected properly. It's hard to test this stuff because the one thing I don't have, and I need to build something, the one thing I do not have is I do not have a board with all sockets on it. I need to build a reloaded board that has sockets everywhere so I can take these chips off and put them in a board, a test board, and know if they're good or not. Because then I can pull all these chips off, throw them in a test board, see if they're good, and if they are, then put them back on, right? Can't do that. So, anyways, we're just doing it the hard way at this point. So, yeah. Let's try it again. Still doing the same thing, but I did make another observation. Now, this is with the third-party ROM, but I took the RAM completely out. There's no RAM in there anymore. It's just sitting here. Look at this. I'm supposed to get the do-do-do-do, but I'm not. So it's freezing before it checks the RAM. That's weird. I gotta look into that. Let me put the stock ROM back in and see what it does. Alright, stock ROM is back in there. I should get death chime straight away. What? No. Unless that's not an SE30 ROM. That's a thing. Hold on. Let me put a known SE30 ROM, because this is confusing the crap out of me. Alright. That I know is an SE30 ROM. So let's try that. Alright. It's like we're playing dodgeball with the ROMs here. Okay, so that's an SE30 ROM. That's what I expected. So what in the world? Is that a 2SI ROM? 3410811. That's exactly what it's supposed to do. That explains why it's not starting up. Alright, okay. Alright. So now we have a good control here. I'm going to put known good RAM, and I'm going to put a known good ROM in there that I know works. Because that sounds like I can't see the RAM error. So, again, those used F258s are in there. Okay. Let me get actual good RAM in there. Alright, so here we go again. My known, there's 1 megabyte of RAM in there that I know is good. The old stuff's out here, so try this again. Okay, yeah, we got a RAM problem. We got a RAM controller problem. Alright, okay, that makes sense now. That explains everything. Okay, so we got to find out what's up with that. I guarantee I know what's up with that, but yeah. Alright, well, now we're getting somewhere. Alright, so anytime you're working on an SE30 board and you're just, you know, getting death chimes. So anytime you're working on an SE30 board and you're getting death chimes, the majority of the time it's because it can't see the RAM. Why can't it see the RAM? Well, you could have bad RAM, you could have mismatched pairs, you can have all kinds of things like that, but once you roll all that out, typically it's one of these 6 F258s that go bad, because there's 3 here and there's 3 here. So what ends up happening is these things go bad and they cause the system not to be able to address, because these are the muxes for the row and column strobes. Because an address bus on a system is linear. Well, these are divided up into rows and columns. So in order to switch a linear address between row and column, you need these muxes, and that's what they do. So if one of these is stuck, it's going to read back and fail the RAM test. So that's typically what goes on here. Now, it's not always the case. These two are new, but these four are used. So I'm going to take these four out, and I'm going to replace them, because chances are they're probably bad. Now, may not be the case. We could have a problem with one of these pals. We can have a problem with that. We can have a problem anywhere, but for now, I'm going to go ahead and pull those out and change them just to make sure that that is not causing my problem, because it'll be far easier to troubleshoot when I eliminate the known trouble spots, and that's one of them. The other problem is sometimes these go bad as well, which I think that's new. That's a 74 F240. Yeah, that's new. Pretty sure that's not, but that is. Yeah, that's probably new. So I'm going to leave that alone, but those are going to go away. Alright, so all of these are replaced, so these are all new now. I got the old ones laying over here. So let's give it a try. Nope. So this board is going to fight me every step of the way, and it's going to prove my ISTJ ass wrong with all of my previous experience. So, it is not going to work. So we've got that rolled out now. It's going to become more and more of a mystery of what exactly is going on here. Man. So, well, got to keep plugging at it. What I'm going to do next is I'm going to check these resistor packs, make sure they're present, and none of the resistors are shorted to any one of the others, because these should be series. These aren't busts, they should be straight through. So I'm going to check all of that. I'm going to do the same thing over here, and I'm going to make sure none of them are shorted to one another, so I can roll it out, because I've seen these resistor packs go bad. Not on the SC30, but I have seen them go bad in like the portable and stuff like that. So yeah, this has been an experience. I pulled that thing back out just in case that was causing me a problem. But yeah, okay. So I've done a little troubleshooting off camera, and I swapped this PAL. Well, before I swapped the PAL, I took the original one, I pulled it off, cleaned it up, reflowed it like I've been doing every other chip, and then the behavior changed. It started boot looping. It would boot loop with one ROM, and then the original ROM, it didn't do anything. Like, what in the world? But what I noticed was, it was, when I say boot loop, it was going chime, 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 and I got to thinking, like, wait a minute, I've seen this happen on the portable when there's a RAM problem. So once again, after I changed the 258s, we didn't have any behavior change. We reflowed that, then we had a behavior change at that point. And this contains the row access strobe from RAM read write signals, so that's important. Now, I pulled one of the sticks out, and it went do-do-do-do. So it did the chime, and then the SADMAC chime, which is normal on the S2SI ROM. So that was good. That was a different behavior than what I was getting before. So then I pulled all the RAM out, and I noticed the sockets were just green. They're the original sockets. He moved the original ones over instead of buying new ones. And I just doused the crap out of them with contact cleaner, and I took my toothbrush and just scrubbed the crap out of it. I got the original SE30 ROM in. Listen to that. It's chiming. It's chiming now. Holy crap, it's chiming now. Whoo! Wow. Okay, now, hold on, let me get that back over to voltage mode. Pull the power out. Let's, I even swapped these PALs, because I have a, one of my junk boards over there that I used to build the other reloaded board. Yeah. So, that didn't help either. I deoxidated these sockets as well because they were nasty. He kept the original sockets. See, if I would have built this board, I mean, I don't have a problem if you're trying to save costs and stuff like that. That's totally fine. But the issue is, when you're reusing a lot of stuff that was exposed to corrosion, of course you can't help but use the customs, right? But all of the other Jelly Bean parts like sockets and 74 chips, buying new ones, it's going to increase the reliability of the board. So I changed all of these because I know they're going bad. These two were new. He did buy new ones of these, but he didn't change the rest of them that were new. So those are all new. I don't know if these are bad or not, but they're going in the trash can. I'm not saving them. So those have been replaced. This is the original RAM that he sent with me. I got mine kind of over here. I'm just going to set it out of the way and put that back over there. Okay. So let's get the machine. Well, I don't have the... Actually, you know what I should do? I should put that chip back on. Yes, I should. I'm going to do that. I'm going to put that chip back on. And then let's put the Mac back up here and see what happens. Alright, will the 15,000th time be the charm? Let's find out. Does it work? Yes, it works! Nice. Finally. Alrighty then. Perfect. Alright, let me get all of the SCSI to SD, well, no, blue SCSI and all of that stuff hooked up, and let's see what we got going on. But, holy crap! Yes, finally! Wow! Alright, now that I have the floppy EMU connected, we can see that we still have issues. It keeps ejecting it and thinking it's not a system disk. I know these are bootable. So, more fun we got to deal with. I wonder if the swim is bad. It might be, because that's where the short was. So, it might be defective. So, alright, so we still got some things to figure out. Just when I thought it was good. Nope. I will deal with the SCSI issue later, but first things first. Alright, I double checked and triple checked the swim chip and everything else, and all the connections were good. So pulled the old one out that was in there, and remember, this is the one that had the short, the weird funny short. So that just came out, and I got another one in there that I took off of a parts board. So we'll give that a shot, and then we'll see what happens. And there we go. So I had to use one. I don't have any extras of these. So what am I supposed to do about that? That's bad. There you go. Moment of truth. Will the FPU actually be any good? Testing the ADB. It passed, of course. Let's see. Testing floating point. Let's turn this down because it's too bright. Floating point passed. Wow, it's actually good. Dang. That's incredible. This is just getting stranger and stranger. So I grab a clean SD card that I know is good. So if I go to Macintosh stuff and I want to say system disks, if I go to the 7.1, which is a 1.4 megabyte disk image, if it tries to read that disk image, it spits it back out. It will not start up a 1.4 megabyte disk image. But if I go to System 7 and then load an 800K disk image, no problem. No problem. It works fine. But it will not work a 800K disk image. So, a 1.4 meg image. That is the weirdest thing. Utilities. I don't know. I don't think any of these are bootable. 400K? No. Anyway, so yeah, it won't boot a 1.4 megabyte image. That is strange to me. Alright, so I put the 20 pin connector back on and I tried that versus the external just to roll it out, and it didn't make a difference. The floppy emulator will not mount a 1.44 megabyte image. Well, it does, but the machine won't read it. So before I started driving down the rabbit hole of trying to chase pins and all of that other fun stuff, I decided to say heck with it, and I went ahead and grabbed a real drive. Alright, so I have a 1.44 megabyte manual inject drive that came with the newer machines. Now, it will work with this board. Obviously, it's not going to, fit in there like that, but it will work with this board and you won't have a problem. So let's rule out once and for all that we don't have a problem with the floppy emulator. And I've used those images in the past, the Lido boot disk image, the 1.4 meg image, and it works fine. Because it's based off of this disk right here. So I'm going to go ahead and open that up and stick this in here. This is a 1.44 megabyte high density disk. So we're ready to boot. Will it spit this one out? No, it doesn't. It's actually working. Alright, so... Oh my god. So that tells me the board is fine. There must be a floppy emulator bug or some kind of a weird firmware bug that I don't know about that's causing this. Yeah, see, there it is. If I do it about the Finder, it's going to show the 1 megabytes of memory. It is, okay, so... And then the info about the volume, it's a high density disk that I made back in 2017, obviously. Alright, so... Okay. There you go. Alright, so now we need to move on to the SCSI problem, because for some reason this thing is locking up the machine. So I'm going to do something stupid here, and don't try this at home. I'm going to plug this straight in with the machine on, which you're not supposed to do, but I'm going to do it anyways. Run Lido and see if it'll actually pick it up and mount it. Oh, there it is. SCSI 6.0.8, and see if it'll mount the volume. Alright, so let's quit that. I actually mounted it. It sees the drives and mounted it. It rolls out the SCSI chip. Yeah, it's trying to mount now. Yeah, there it is. Oh, it's only mounting one of the two. Which one did it mount? The 200 meg. Okay. So, what version of software is this? I don't even know. But apparently, the 40 meg system startup. Ooh, wait a minute. So the Macintosh HD image actually melted. It melted. No, it mounted. But it's not. The other one is not. This weird. Yeah, I don't know why. I think. Hold on, let me update the disk driver. I wonder if that's what it is. Blech. Okay, nope. I think this contains a diagnostic thing for the portable, because I remember connecting to a portable. Boop. No problem. That might be why. It's not enough RAM. Let me unmount that. Try to mount it again. And this is further up the boot chain. Or no, actually, that's further down the boot chain. Never mind. Nope. Alright, so... And I guarantee if I restart this box, it's going to lock up. Alright, so... I bet it does. Yep. Something about that disk driver that image is using is not compatible with this hardware. That's got to be what it is. Alright. Anyways, moving right along. Alright, so just to roll it out, I updated the firmware to the latest available version because apparently there's a bug with the 1.4 megabyte HD images. So I did that. System disk, 7.1 installer, disk tools, which is a 1.4 meg image. See what it does. Same problem. Throws an X. So that is not the issue. Let's grab my SD card here and reset this device. Now, like I said, this particular image right here, Lido boot, is the exact same thing as this. It's the exact image. Try to read it. Nothing. Nope. It's just throwing it. Do an 800K image. No problem. So, there's something up with the way this board works with the floppy emulator. It will not mount a 1.4 megabyte image. There's some kind of a weird timing variation that's this thing's not liking. And that is it. So, besides the weird issue with the timing and the floppy emulator not being able to read 1.44 megabyte discs, I don't know what's going on with that, but the real drive works. And the SCSI works. I finally got the SD card set up on the blue SCSI. Everything works fine. It passes all diagnostics. So, I think I'm going to call it for this board. Wrap this guy up. Everything is working properly. I have sound. So really, to recap what we had to do, we needed a new one of these because it wasn't working at all. Not even 800K, so we had to put a new swim in there. We also had to pull all the chips. Besides this one, we had to pull them all, clean them up, remount them to fix the majority of the problems. And then I had to replace the 258s and clean the sockets, and then that brought everything alive. So, we got that out of the way, and we can now wrap this up. So, I think that's going to do it. So we can set this guy away. We got all the bad ones over here, pile of parts. And then for that particular person, that's going to do it. But then I opened this other bag and, well, oh boy. But that's for a different video. Anyways, if you like this video, don't forget to hit the subscribe and like button and, you know, the whole 9 yards there. If you have a comment, please feel free to leave one. Thank you for watching, and until next time, guys.